Good morning, good afternoon. Welcome to today's webinar. My name is Jeffrey Palermo, and I'm your host for today's webinar. We're going to be talking about effectively leading your software team and avoiding rookie mistakes. And I'm excited about this topic. I've had so many conversations lately in our um, software software executive leadership forums, and I'm gonna cover some really common ones that happen, unfortunately, too commonly, and I'll give you some tips for how to get around them. So let's jump right in because we have a lot of material and not a lot of time to cover it. So a little bit about Clear Measure and a little bit about me and the dirt bike racing slide that you didn't see and the free ebook. If you send me an email or put in the chat, um, thanks Richard for that. And yeah, here is the agenda. So now you should be seeing the um, the items that we're going to go through. So you can take a screen grab of this slide and um, and these are the ones we're going to cover. All right. Um, I have a new book. We have the Kindle version out. And actually, I need to forward the slide here. The Kindle version is out, and if you search Amazon.com, you can find it. You can search, Five Pillars Software or Five Pillars Palermo, or just click on the link, or you can point your phone at the QR code right there. And and the Kindle version is out, so you can get an electronic copy of it right now. And if you just kind of ask me for it or in the chat, we will send you a free copy of it. We have a promotional price on Amazon because it just got released, and the print version is coming very soon. We're just about to pull the trigger, send it to the print publisher, and then that'll be online as well. But you can get the electronic copy right now on Kindle, and within a month, we'll also have an audiobook version of it also. And um, and some of the quite a bit of the material that we're going to cover today is also touched on in the book. But if you are overseeing or running a software engineering team, I would consider this just a must read, a must read. All right. So our philosophy at Clear Measure, we have something we call the Clear Measure way, and it's how we think about software, and it's how we execute our own client projects. And we have a belief, when equipped and trained properly, we believe that every software team can be successful. And so the Clear Measure way simplifies and synthesizes known practices in a manner that any software team can implement. If you just search our website, you can see various tools like a self-assessment, a team alignment template, to get the team aligned in the right direction, and also a scorecard, which is one of the tips here. And I touched on, we have two monthly software forums, interactive forums on Zoom via video call, and one for software architects for the technical side, and the other for managers and executives of people overseeing software teams. All right, so let's get right into it. Now, the reason we want to avoid rookie mistakes is because we don't want our project to fail. Overall, our industry has a pretty poor success rate, and that's unfortunate. If you look at statistics from the Standish Group and others, only around 40% of projects on average are successful. Now, there's more projects that complete, but not necessarily successful. When the executives who allocate the funding and commission the project, when they regret doing so, when they wished they hadn't, the project's not really a success, even if it kind of finishes. And of course, we've got some really spectacular failures over time of spectacular failures, but there's a lot of troubled projects, and ultimately you want your project to be a success. And so that's the lens that we're gonna look at here. Um, the five things to think about to avoid all of these rookie mistakes are these five pillars, and they're so important. I wrote a book about them: creating clarity, and then establishing quality with the software, then as the software is running in production, achieving stability, and then armed with those previous three, then incrementally increase the speed of delivery, throughput of changes and software features. And then we cycle and do it all again as we optimize the team and optimize how it's going. All right. So the first rookie mistake that we're going to jump into is that the project is too big. So when you are, and by the way, these are not rookie mistakes of programmers. Again, this is an executive level webinar. This is as you are running your software team, or you may be overseeing multiple software teams. These are rookie mistakes of software leaders. And as a software leader, you kind of decide how big the project should be. If you have a massive software initiative, well, you need to chunk it up into individual projects. Let's look at some of the data. In the 2015 Chaos Report, there were some details around failures and successes. And one of the differentiators, besides methodology, was the size of projects. And on average, pretty dismal success rate. But if you look at small size projects, and if you dig into the details, it's small projects that are 10,000 function point equivalent or less. And if you don't know what that means, you want to look it up, because there's some rule of thumb: 52 52 lines of code in .NET for one function point. So you just multiply it by 10, and roughly, if you're north of 500,000 lines of C#, then you can't call your project a small project. But that's where we're going to get into the medium-sized project. But the small projects around 1,000 function points or 52,000 lines of code, those are not the medium-sized projects. Those are the small projects, and those have a much better success rate. You're looking at 58% for Agile and even 44% for Waterfall. But the large projects, you're down at 18% success rate, even with Agile. So one of the rookie mistakes is allowing your project to get too big. If you have a lot of stuff to do, you want to find ways to break it into smaller individual projects and have a stream of projects where no single project is too big. You want to finish a project and then move on and have smaller chunks. And so if you look at a code base, just to clarify, I kind of ran some numbers together. If you have a software system that's over 52,000 lines of code, you can't say that it's a small project. And then if it's over 500,000 lines of code or 520,000 lines of C#, then it no longer classifies even as a medium-sized project. You're into, above 500,000 lines of code, you're into the large-sized project. And if you're, million lines of code, you're well in the large-sized projects. So that's where you look at the statistics of average success and challenged and fail rates and make your project size accordingly. All right. Next rookie mistake is to have isolated developers. All right. What do I mean by that? Well, let's look at the Agile Manifesto back in 2001, uncovering better ways of developing software by doing it and helping others do it. By the way, I just had the privilege of interviewing Jeff Sutherland on the Azure and DevOps podcast, which I don't have a link for it, but if you search for Azure or DevOps in any of the podcast directories, it's usually on the first page of results, the Azure and DevOps podcast. And Jeff Sutherland was the creator of Scrum in the late 80s. And then in the 90s, extreme programming was the other methodology. And so some of the consultants and the creators of those got together in 2001 and talked about software methodologies and better ways to do it. But Scrum actually came from, well, I'll let you listen to the podcast for the history of all that. But let me jump into the Agile principles behind this manifesto, because yeah, we heard of these values, but a lot of people really don't read the principles, the 12 principles that are attached to the Agile Manifesto. And number four, business people and developers must work together daily throughout the project. What a rookie mistake is to insert an intermediary between the developers and the actual business people. And it can come in a number of forms. It can come in the form of a business analyst that comes from the IT side that's not in the business group, or it could come in the form of a product owner that is not is not a business person, um, because the principle, it's pretty darn clear. Business people and developers must work together daily throughout the project. The bad thing that happens is that without that, you have the intermediary listening to the business goals and then coming up with ideas for what types of software features would accomplish that business goal, and then giving it to the developers as a definitive definitive scope. These features must be done. The project is defined as a set of these features. When in reality, the project is being funded because we want to accomplish a business objective. So that's one of the rookie mistakes, is isolating the developers instead of uh, principle number four, which is having all of the developers actually working with business people together on the project, right? Next rookie mistake, unclear objectives. Now, you can kind of a spring off of the previous one. If developers are not working together directly with the business people, then, over time it can be unclear what the actual objectives are. And it might seem like the objectives of the project is to just crank out some number of features, and that's not correct. Some of the thing, what that might look like if there's an actual misalignment, um, is uh, is some of these quotes. We've already built our backlog. Now we're working to burn it down. We already know the features that we need to build. We need to get more development done faster. These are all the required features. Or the subject matter expert has said that we have to have this feature. Or this feature still doesn't work the way that the product manager wants it. So there is um, there's some research now that's probably 5 or 6 years old that basically basically found that when you had an intermediary who was not a business person, what was found that a third of the time a feature was put into production, that it had the positive intended effect, and a third of the time that a feature was put into production, it had a neutral effect. It didn't actually accomplish the objectives, but it was fine. And then one third of the time that the prioritized feature was put into production, it actually had a negative effect and had to be reverted quickly because it was actually causing damage. So it's uh, so important that we don't isolate our developers, and also for them to have a very clear understanding of the overall vision and what we're trying to accomplish. All right, the next rookie mistake is having a missing scorecard. And this goes to how we actually report status. The good old status report. Um, Status reports that are English, that are just a paragraph of what was worked on, what the activities were this last sprint or iteration, what the activities will be, or what features are going to be worked on the next iteration. Those don't have many teeth. Those don't actually tell an executive what's going on. It just says, "Hey, we're working here and we're really trying hard and there's some activity going on." But it doesn't actually tell the status of the project. Instead, just like every other function of a business, in order to actually measure it and know what's going on and what's being accomplished, you need numbers. You need a scorecard. The status report needs to be numbers. And the fancy word for numbers is metrics. And then you can turn a metric into a KPI, or key performance indicator, by defining a threshold, a high and a low, for a metric to be, green or yellow or red, good or neutral or warning or bad. And so um, there are a minimum of three categories where you absolutely need to define numbers when you report status. Uh, and from the leader's perspective, when you receive status from your team, you need numbers around quality that is being produced, number of defects that are slipping through, number of defects fixed, defects produced, because ultimately you want to have the team prevent every defect. And the other category is stability. As the software is running in production, you need to know how many production issues, how many disruptions, and how many are being resolved, how long it takes to resolve each one. Um, and a lot of these metrics have been around for a long time. You just need to get them reported from your project each week. And then the third category is speed, overall throughput. How fast is the team getting out changes and features? And none of these metrics are complicated in and of themselves, but that's one of the rookie mistakes is allowing a team to report status up to leadership in the company without actually reporting any numbers, or to maybe only report numbers for as number of features delivered. But we know that without establishing a high bar of quality and without achieving a high level of stability, there's no way for a team to deliver software at any acceptable speed. So that's one of the rookie mistakes. The next rookie mistake is to have the team lead with code, or to have a project actually jump into the code first. And I'm going to share a few things here about code and defects. One of them is from research published by Capers-Jones. This one's from 2012, and it's software quality metrics, some harmful metrics and some helpful metrics. But in it, he pulls from 19,000 cataloged projects some research about the sources of defects. And he pulls the research from C-based languages and Java-based languages. So what he found was that for every roughly um, for every 32,000 lines of code, you can see down there defects per KLOC. Um, about 10 of the defects actually came from requirements or faulty analysis, basically faulty decisions about what to do. 20 of the 32 and a half came from design, figuring out how we're going to do it. And then 30 came from the actual code. 30 were actual programming errors. And then 3 of the defects were problems in related documents. And then 2 of them were bad fixes where we were going to fix a problem and then we actually introduced another one. So you can see that slightly less than half of defects on average come from actual code. So I need to think about that because uh, making bad design choices or design mistakes and then faulty analysis or analysis mistakes, those are actually, the other half. All right. Along with the rookie mistake of jumping right into code prematurely, we need to actually have a full process for how we're going to flow through code and get it into form of working software that is used. And so that's the good old DevOps environment, and you want to have a good structure for it. I've shown architecture diagrams like this in quite a few webinars, but if you're seeing it for the first time and don't have it, we have a um, we have a 2 foot by 3 foot high resolution DevOps architecture poster that as a resource for your team. And if you'd like the high resolution digital copy of that poster, just put it in the chat or send me an email and we'll make sure that you get it. You can send it to any print shop and get it printed on architecture D paper, which is 2 foot by 3 foot, and put it in your team room. In addition to prematurely jumping right into code, we need to have a work tracking system that gives us some visibility into the activities that need to happen before code can be written. And there's four design decisions that really have to be made before we know what code to write. The first one, conceptual definition, that can also be translated just requirements. And so I think the historical term has been requirements analysis, or just deciding on what the concept is. But that's a decision. What is this feature? What are we trying to accomplish? What are the characteristics of it? And then after that, we need to make decisions about user experience. We need to decide how a user of our software is going to use or experience this particular behavior, even if it's a backend batch job or a backend message processor that just moves data around. The user experience decision would be, how long is it okay to wait until data moves from point A to point B? That would be part of the user's experience. Should fresh data get moved, every every 1 second, 5 seconds, or is it okay to, have data move, once every 6 hours? Those types of decisions all go into user experience. And then after that, there's the technical design. What architectural elements need to be added to the system for this new feature? What libraries, what design patterns, those types of things. Those are all decisions. The next decision is test design. Given what we know about what we're trying to accomplish, how we want a person to use it, and how we're going to implement it technically, how are we going to test this feature? Once it's in place, what are the buttons we're going to click? What are the screens we're going to progress through? How are we going to verify that this actually works? And what scenarios are in scope, and what maybe edge cases or exception scenarios are we going to include versus intentionally not include, and just maybe leave with a not supported or just not available. And so that's test design. We need to decide what scenarios of behavior we want to be relevant in this feature. Only then can we write the code. So the rookie mistake is to have have the developers on the team jump straight into writing code, or to have an insufficient process where you only have 3 columns on your work tracking board that say not started, in progress, and done. Because then you have no idea what's actually being done or where the bottleneck is. All right, so that is a rookie mistake, is that the team has led with code. Next rookie mistake is insufficient quality control. We all know from experience, and kind of everyone on this webinar has been in software for a good amount of time, that defects that escape out from the development team out into the wild are orders of magnitude more expensive to fix than if we fix it very close to when it was created. And so there's different feedback cycles that generate this order of magnitude effect. And so the concentric circles, if an individual developer is writing code if I'm writing code on my own workstation and I make a typo, or I break the build, or I introduce a defect and a screen blows up on me, well, I haven't shared it with anybody, so I can fix that, relatively quickly. But if there's a problem and already been merged into uh, the master branch with an accepted pull request, and it's at the team level, well, now that bug is a lot more expensive to fix. And then if the team produces a release candidate and sends it to to the product level, to product management, or to an outside team to start testing things, and the defects found, well, that's another roughly order of magnitude. And then if it's in production being used by the actual software users or customers, and then the problem is found there, and it comes in the form of a support ticket, well, you get the gist. Okay. All right. So Barry Boehm, back in 1976, one of the very prominent software engineers, leaders of the industry in that era, is quoted as to say defects kill effectiveness and they're a recipe for failure. And so um, this rookie mistake cannot be understated, that we must give attention to defects and quality and have sufficient quality control. So the rookie mistake is insufficient quality control. You need to intentionally think about it and have a strategy for that. Um, W. Edwards Deming, who led the quality manufacturing revolution and did a lot of publishing when manufacturing was increasing with the total quality movement, is quoted to say, "If you can't describe your plan, you don't know what you're doing." And just to give you a sense of a plan for what, well, um, this is the Deming chain reaction. You need a plan for improving quality, because improving quality leads to decreasing costs. You have fewer mistakes, less rework, fewer delays and snags, better use of the servers. And then that causes productivity to improve. I want to emphasize that. You can't have your team increase productivity until you figure out how to increase quality. Improving quality causes productivity to improve. And then when productivity improves, you're able to do more interesting things. Your company can capture more market share, or you can lower prices, you can stay in business, you can grow the business, and you can provide more jobs, and now you have more people, and now you can innovate better and improve quality yet again. So that's the chain reaction. Now, for the, I just want to highlight all the work of Deming. Now, he passed away in 1993, but he published hundreds of papers and articles and books on quality control. So he's definitely worth researching if you're not familiar. The next rookie mistake is poor engineering hygiene. Poor engineering hygiene. And these are just the basics. Think of it as just the ticket to the game when you are going to be doing you're going to be running a team that's doing software engineering. There's things that are just basics. It's not that they're necessary in one type of software, but not another type of software, or a certain mix of technology, but not another mix of technology. It's if you are building and running custom software, there are certain things that are just at the status of basic hygiene. And without them, your team is going to be doing nothing but fighting fires and just fixing problems. The problem with fighting fires is that firefighters, they don't build anything. All they're trying to do all day is to minimize destruction. That's not the situation that you want to lead your software team to be in. Let me just kind of highlight that a little bit. So software quality and engineering practices that lead to software quality have to be the biggest priority for a software engineering team, because it preserves the ability of the team to continue working on the software. If you don't, then as the number of escaped defects to production increases, the percentage of the entire team's capacity to work decreases. 50 years ago, Fred Brooks wrote a book of essays called The Mythical Man Month. And Fred Brooks was a software engineer on the early IBM OS 360 project in the late 50s. And one of the essays in the book is called The Tar Pit. And the main idea of this analogy is that low quality software is like a tar pit. The more you fight it, the deeper you sink. No one single thing seems that difficult, seems that big of a problem. You should be able to pull 1 foot out of the tar, but you still can't get yourself out of the pit. And this is what happens when high quality isn't established right away, or rigorously maintained at a high level. And so you definitely don't want your team in the tar pit. All right. So what are the basic engineering practices that are at the hygiene level? One of them is your private build. Answers the question, is what I did is my change ready to commit to source control. You have to have an automated private build process that developers can run locally that quickly tells them the answer to that question. Now, we're not talking about just compiling. So one of the next practices is test-driven development. This is the practice of growing your test suite, growing your body of automated tests with every change you make to the system. It's not that at periodic times you come back and add automated tests. It is the practice of defining the writing of tests with the steps where you're implementing every feature. And it even includes, a process by which to write the tests, write failing code, red, green refactor. I'm not going to go through all the ins and outs, but at the executive level, the test suite should grow with the lines of production code. And what happens is you end up with a private build that runs all the previous tests of every previous software change, so that when I as a programmer make a change, I run my private build locally, and I have confidence that I actually haven't broken any previously developed software behavior. All right, another hygiene level practice is static analysis. And there's all kinds of tools that do static analysis. Um, uh, JetBrains, ReSharper, Inspect, Sonar Cube, Independ. There's all kinds of tools that can integrate into an integration build and just run behind the scenes and check things and call out problems. Some of the guidance from Capers Jones, who kind of catalogs all the research, is if you do upfront inspections and if you use static analysis before testing begins, your schedule will be shrunk by at least 50% and your software quality will be above 90% defect removal efficiency, meaning you'll prevent 95% of possible bugs. And this is not just a pitch. This is his conclusion from researching over 19,000 software projects over the last 30 years. And what it means is static analysis before testing begins. He's talking about before manual testing begins with an actual release candidate delivered to somebody outside the team. So upfront inspections, static analysis is a type of inspection, inspecting the code. Now, the inspections research also applies to technical design and user experience design and requirements analysis. All right, the next rookie mistake is deferred ops design or deferred operations design. How are we going to run this software in production? Or as we're changing an existing software system, how are we going to know? How are we going to operate the new capabilities? How are we going to operate the new extension of the software system? And how are we going to know that it's operating well? And how are we going to know early warning signs if something about it starts to operate differently than well, so that we can prevent one of our users or customers from, complaining because they can't conduct business. This is a big topic, but this is where DevOps came from. And if you don't know the story of the genesis of DevOps, it might be worth looking up this short video on YouTube. It's on the Damon Edwards YouTube channel. You can just search for this title, The Short History of DevOps. And you can see that the word DevOps wasn't the original word. The problem that Damon Edwards was wrestling with was how to apply the Agile Manifesto to systems administration, because the Agile Manifesto was kind of brought forth by programmers, and all these new ways of working kind of invaded the programmer space first, but servers were still very manual, and operating servers and changing servers, and even in the era of cloud, there's a lot of teams that are provisioning things in the cloud just as manually as they provisioned servers in a data center. Maybe without the actual mounting of the server in a rack with a screwdriver, But Agile System Administration was the original title of DevOps. And so that should give you the the kind of imagery in your head. How do we run our systems? How do we keep our systems online? How do we make sure that they continue to behave well, but apply the agile values and principles to them? And so you want to be intentional about that and not just defer that, because the second that you have anything being used by a real person, you need to be good at running it and knowing if it's about to stop running well. Okay. Next rookie mistake is not making all work visible. And it's interesting that the first way of DevOps, there's three ways of DevOps. The first way of DevOps is make work visible. And if you're not familiar with that, the Phoenix Project by Gene Kim and Jez Humble kind of outlined that. So if you haven't read the Phoenix Project, which is the first in a good DevOps series, then I'd encourage you to read that book. But you want to make all work visible. Now let me jump back to this Kanban board that I showed you previously. This board kind of does a few things for you. Yes, it orders the design decisions to be made before it's time to write code, but it also outlines every activity necessary for a particular feature or software change, all the way from thinking about it to the software being used by somebody in production. And you can see the symmetry with the code in the center, and then decisions being made before code, and then verification being made after code. So you can kind of see that symmetry, and the descriptions of what needs to be done on each stage are in the boxes in the bottom. And by the way, this sample work tracking board is in chapter 4 of my .NET DevOps book. So you might want to read chapter 4 of that book, .NET DevOps for Azure. But there is a danger in some work not being visible. For example, if you don't have these 9 columns, and by the way, I don't care what you call the columns, you can rename every single one of them, but you need columns that represent this concept. If you have a board that just has not started, and then in progress, and then done, then it is invisible to the executive overseeing the software team if a feature is just blocked and not progressing. Because if we just move it to in progress, we have no idea if we're thinking about what the goal is, which is requirements analysis or conceptual definition, or are we still trying to figure out what the screen should look like, which is really user experience design. Or maybe we don't know how to implement it yet. Maybe we're trying to find the right library to use to make this thing technically feasible. Or maybe we think we're done because we didn't do any test design. And so we think we're done and we're about to push it on, but maybe there's a few scenarios that we literally didn't even do. If we were doing a login screen and we wanted to, show, if we wanted to lock a user's account after 3 consecutive logins. Now we don't write our own login screens anymore these days, but just for the sake of argument, we might do a login screen where you type a bad password, there's a message, and then we go forward. And then, of course, somebody in product management is testing it out, and they just do bad password after bad password after bad password. And then they raise the objection and says, wait a minute, somebody could just sit here and try to guess somebody's password for forever. Shouldn't we stop that after so many failed attempts? Well, that's a good idea, but when I started writing the code, that wasn't something that I set out to do. And so now we have an objection later on because some particular work was totally invisible until somebody late in the testing raises their hand and says, wait a minute, this is what we should have done. Okay. Or maybe there's 10 features that are all quote in progress or in development. But what if all 10 of those features are really sketching out what the shape of the screen should be and where buttons should go and what labels of text boxes should be called? Well, now we have 10 features where we're trying to figure out what the screens should look like. We're actually not writing any code yet, and we're not doing any technical design yet. But that's invisible if you don't have a work tracking board, which has all of the activities in the software development lifecycle. So that's why it's important that that we make all work visible. All right, the next and the last rookie mistake that we're going to cover today is to have a high work in process or a high WIP. And the premise here, the bad thing that happens is that software that isn't being used is just a hypothesis. Remember the research back in 2018 or 2019, the I believe it was Puppet Labs, the state of Agile, or the state of Scrum, and the research was a third of the time we're right about a feature being a good idea. Third of the time it makes no difference, and a third of the time it was an actual bad thing to do and we need to back it out quickly. Well, if we built software, even if we've tested it internally and okay, it works the way we said it was going to work, but we haven't actually had our customers using it or our business people using it, it's still just a hypothesis. On average, a third of that work in process is going to be useful, and 2/3 is not going to be useful. And so we want to limit the work in process. We want to build something, change something, and then we need to get it into the hands of the people that are actually using the software. And only then can we stay as close to or keep our body of hypotheses as small as possible and get not real-time feedback, but get very quick and frequent feedback from the people who are actually relying on our software to do their jobs. So those are the rookie mistakes. Some of the resources that we can help out with. We have a software leaders handbook that you can find on clearmeasure.com/software-leaders-handbook. Pretty easy to find. And also inside the 5 pillars book, there are chapters on each of these: create clarity, establish quality, achieve stability, increase speed, and optimize the team. So I'll put back up the screen grab of the Amazon page. And I would highly encourage you to get this book. Again, we have a free promotion going on. You can get a free Kindle version, electronic copy of the book now. And in about a month, we should have hardback and paperback copies available. And of course, if you do get the book and read it and you like it, we always would appreciate another Amazon review relating as such. So thank you very much. I'll leave this up. And I think I preserved some time on the calendar. I didn't use up all the time because your time is very valuable, but I will stick around because we have a couple of questions, and I'll make sure that all the questions get answered at this point. So we'll move into Q&A. One of the questions is, what's your opinion of executable specifications defined by acceptance tests? I'm in favor of those, and I'm in favor of every tactic that makes the team more effective. And so there's all kinds of technical practices and methods that people have figured out over time that have proven to be useful in many cases. Use them. There's so many good things that teams can do. All right. Another question is, any opinions on best practices for ETL platforms such as Azure Data Factory? My opinion on those types of things is is just like any other tech. There's so much available technology out there that is good and useful as long as we make intentional decisions about how it's going to fit in a user experience and how we're going to technically implement it to support some software features. On our sample work tracking board, we have conceptual definition and user experience design ahead of technical design. And so the principle I would pull from that is we need to really understand the business objectives and what kind of capabilities that we're looking for and how we want our users to be able to use the software when we set our minds to selecting architectural elements, design patterns, and specific technologies, because then we'll make the right decision. If we start thinking about the technology stack before we really understand from the business people what the objectives are and what environment the software needs to work in and how they need to use it, well, then invariably we're going to go sideways and we're either going to make poor technology selection choices or we're going to implement those technologies in a way that doesn't actually solve the business people's problems. So hope that helps. Hope that helps. All right, I think I answered the other questions in line. So we have those giveaways. Just see Johnny in the chat or send me an email and request those, and I will leave my email address up at the beginning one more time. And thank you so much for your time. I hope this is helpful, and have a great day, and God bless.